About the question number 12, which says let y1x, y1 and y2 x form a complete set of solution of the differential equation 0 1 with y1 0 is equals to 0, y1 dash 0 is equals to 1, y2 0 is equals to 1, y2 dash 0 is equals to 1. Then the Wronskian wx of y1x and y2x at x is equals to 1. E square b minus c minus c squared d is so it is important problem, and how to solve this problem is that first wx is equals to integration of minus a1x, that means a1x by n naught x of dx. So this is a1x and this is n naught x, so it is equal to e to the power minus integration on twice xy minus twice xy by 1 dx. So t is equals to twice x of 4 e to the power minus 2 of e to the power x square, right? E to the power x square. This is a now w of 0 is equals to y1 0, y2 0, y1 dash 0, y2 dash 0 is equals to y1 0 0, y2 dash 0, y2 0 is equals to 1, y1 dash 0 is equals to 1 is equals to minus 1. Therefore w of x is equals to a e to the power 0 is equals to minus 1. This implies a is equal to minus 1. Wx is equal to minus e to the power x square. Therefore w of 1 is equals to minus 3. So B is correct, right? So B is correct. That's how we have done it, right? It is quite important. And so the next problem, we will go to the next problem. So next problem is question number 13. It will be 13. We are doing series of problems of differential equation, solution of ordinary differential equation d2y dx2 minus y is equal to e to the power minus x such that x belongs to R, then where so this is our solution such that y of 0 is equals to dy dx of 0 is equals to 0. Then y attains its minimum on R. P y is bounded on R. C limit x tends to infinity e to the power minus x yx is equals to 1 by 4. D limit x tends to minus infinity e to the power x of yx is equals to 1 by 4. So which of the following is true? Now to find solution, answers of the problem. So d square minus 1 of y is equals to e to the power minus x, right? Y0, then this is quite important. D is equals to plus minus 1, y is equal to a e to the power x plus b to the power minus x, right? Now y of 0 is equals to 0 is equals to a plus b. This implies a is equals to minus b, right? Now y dash is equals to a e to the power x plus b minus b to the power minus x. Y dash 0 is equals to 0. This implies a minus b is equals to 0. This implies a is equals to b. B is equal to minus a is equals to 0, right? So y0 is equals to 0, therefore yx is equals to 0. So for all x, that means y is bounded on R, its minimum on R, y x is equal e to the power minus x, yx is equals to y is bounded, yx is clearly 0. No, this is false, right? This is false because pi is not pi. You have to find pi, right? So for pi we have to find pi over 1 by d square minus 1 of e to the power minus x. So that means d minus 1 of whole square minus 1 e to the power minus x. That means 1 square, sorry, it is equals to 1 square, that means 1. So it is equals to x by twice d into e to the power minus x is equal to x by 2 integration e to the power minus x. So x by 2 of minus of e to the power minus x. Therefore y is equal to a e to the power x plus b e to the power minus x plus minus of x by 2 e to the power minus x. Y0 is equal to 0 equal to a plus b. This implies a is equal to minus b, and y dash equals to a e to the power x minus b e to the power minus x minus half of e to the power minus x minus x by 2. So plus, it will be plus e to the power minus x, right? E to the power plus x. So y dash 0 is equal to 0 is equal to a minus b minus half a this implies 0 is equal to minus b. We can write a plus a minus half. This implies twice a is equals to 1 by 2. This implies a is equals to 1 by 4, b is equal to minus 1 by 4. Therefore y is equals to 1 by 4 e to the power x plus 1 by 4 of e to the power minus x minus x by 2 e to the power minus x. Now limit of x tends to infinity, y to e to the power minus x into yx. So 1 by 4 minus x, right? So it will be 1 by 4 e to the power minus 2x minus x by 2 e to the power minus 2x. X tends to infinity, so this goes to 0, this goes to 0 is equals to 1 by 4. So c is through e to the power x, and x tends to infinity minus of infinity e to the power of x yx is equals to e to the power x yx. So 1 by 4 of e to the power twice x, then it will be 0. So minus 1 by 4 it will be 0, and it will be minus x by 2 only, and the x tends to minus infinity. So minus infinity, this will be 0. But what is problem? This x will minus infinity will send it to infinity, so this false. Why it is its minimum on R is bounded on R. To check boundedness, right? Now say x is infinity, then bounded on R. X is infinity. If to check boundedness, if x is infinity, x is equals to infinity, then this part goes to infinity and this part goes to 0, this part goes to 0. So this part goes to 0 infinity. This implies y tends to infinity, so y is not bounded, right? So it is clear that y is not bounded. Y attains its minimum on R. So that is nice question. That means it's a whether it attains its a maxima or minima or not. Why does if we try to find y dash, then certainly this will be y dash. So y is equals to this. So y dash, from here we can find y dash, but y is attains its minimum or not, that's an critical question, right? So y dash 0 is equals to 0, y double dash now coming to the most important thing, that is whether y attains its minimum or not. So what is y is equals to, it is clearly we can see y is equals to 1 by 4 e to the power x minus 1 by 4 e to the power minus of x plus what is y, minus x by 2 minus x by 2 e to the power minus of x. Now y dash x, so y dash is equal to 1 by 4 e to the power x plus 1 by 4 e to the power minus of x minus x by 2 e to the power minus x minus half of e to the power minus x by, so y dash x is equals to 0 if we take, then y plus 1 by 4 e to the power minus x plus x by 2 e to the power minus x minus e to the power minus x is equals to 0. This implies 1 by 4 plus 1 by 4 e to the power x, right? So other terms contain e to the power minus x, so e to the power minus x 0 dividing by e to the power minus x, so it will be e to the power twice of x plus, if we take y dash of 0, say 1 by 4 plus 1 by 4 plus half minus half is equals to 0. So now y double dash x, y double dash of x is equals to 1 by 4 e to the power x minus 1 by 4 e to the minus 2x plus x by 2 minus x by 2 e to the power minus x plus half of e to the power minus x plus half of e to the power minus x. So this this will give 1, that means 1 by 4 e to the power x minus 1 by 4 e to the power minus x by 2 e to the power minus x plus e to the power minus x. Now y double dash of 0 is equals to 1 by 4 minus 1 by 4 so 1 by 4 plus 1 is equals to 1 greater than 0, so 0 x is equal to 0, x is equal, so what we get is x is equals to 0. That means what we can say, that x is equals to 0 is a point of minimum. So that's it.